All right, use the properties of logarithms. So here's the question. Before I move on to the question, we need to take note of some properties. So I want you to pause the video right now and write all of these down. You don't need to necessarily memorize how, or not memorize these equations, but you do need to memorize how to use them. So pause the video, write these down, and then go back to the problem. Okay, so the problem we have is log of 5, and that's a base 10. We'll talk about that in a second. I don't think I've talked about that yet in my videos. So here's a question written down. Kind of like when we write, let's say, x squared plus 2x plus 4. Well, there's assumed to be a value out here, right? That value is 1. And there's also assumed to be a value right here, which is 1. And there's also a value right here, which we've been talking about for logs as well. We don't always write these ones because it's just kind of annoying to do it all the time. Well, there's another thing that we don't always write when we write logs. A lot of times we've been seeing log base 5 of 25, which would equal 2. 5 squared is 25. If the base is not written, then it's assumed to be 10. So both these bases are 10 right now. Doesn't actually matter. I just want to talk about that. So you could write it in here if you want to. We don't need to. I already did, so I'm going to leave it there. All right, so using these properties, we have an addition problem. So we're using this property, which means that we're going to combine them into one log and multiply those two numbers. And you see our base, the base must be the same. And our base is the same in this situation. If you'll notice in all of these things, our base must be the same all the way down for at least product, quotient, and change of base. There's only one base here, and there's only, actually no, both bases here are the same as well. Okay, going back to our question. So if we're adding them, that means that we write it together as 1, but we're multiplying the numbers inside, so we end up with log of 10. And once again, our base is 10. We don't need to write it. If you wanted to put this one in here with the log of a new b, or a new base, you could, but you just have to write 10. They would both be right. And the answer, log 10 to what power equals 10? It's going to be 1 as well. The actual answer to that log question. All right, next question. We have a subtraction problem. So it's log of base 10 of 10 minus log of base 10 of 2. So we write those two numbers as a division problem using these properties. If we subtract, we take the first number and we put it on top, take the second number and put it on bottom. So if we go back to our question, we're going to have 10 divided by 2, which would be log of 5. All right, next question. Log 2 times log of 4. Okay. So once again, we're using this setup. So we see right here, we have log and a 2 out front. So we got to see where this p goes. So the p is an exponent on our x on the inside. Okay, so I'm actually going to write this down on my board. Log base a x p is equal to log base a x. Okay. So here's our question. Here's the formula we're using. So here is our p, our log, our a is 10, and then our x is 4. I guess I should have color-coded all these things. I'll do this. Yeah, I don't know if that helps or not, but okay. So we got to rewrite it in this form. So everything is really more or less the same, except this 2 just becomes an exponent on top of our 4. Okay. So log base, which is 10, we don't need to write it. 4 squared is our answer, which is going to be 16. Okay, so it's an addition problem, just like the very first one. So going back to our properties, we're going to multiply them. We have x plus y, so we do x times y. So looking over here, 3 times 4